So let's look at a problem about normal distributions. On the driving range, Rory McIlroy practices his swing with a particular club by hitting many, many golf balls. Let x equal the distance the ball travels on a randomly selected shot with his driver. Suppose that x follows a normal distribution with a mean of 304 yards and a standard deviation of 8 yards. So Rory has done a lot of practice swings and they figured out that his average is 304, the standard deviation is 8, and it follows a normal curve. Find the probability that a random drive, a random ball of his travels no more than 290 yards. So we've done normal curve problems. This is nothing unusual. So let's start to look at this. Okay? So here is the normal curve. Okay? So in this situation, notice that 304 is in the middle, and I have marked the standard deviations out. The standard deviation was 8, so if you go 8 units to either side, you get 312, 320, 328. You also get 296, 288. Those are the standard or regular values of 1, 2, 3, even 4 standard deviations out. As a matter of fact, you can see that I've put z scores underneath those because that's the same thing. A z score of 1 means you're 1 standard deviation away. So 312 is the same as a z of 1. Now, we're interested in the chance that his ball goes no more than 290 yards. We see here that 290 yards is not either 1 or 2 standard deviations below the mean. We see that it's below the mean, but it's neither one of those. As a matter of fact, it falls somewhere between them. We're interested in he said no more than 290, so it's 290 and below, so we're interested in that area that we see there. But that's not one of our standard 1, 2, or 3 standard deviations. So we can't use the 68, 95, 99.7 rule. As a matter of fact, if we use the work that we just did calculating z, we can find out that it's 1.75 or 1 3/4 standard deviations below the mean. So see how I did that? 290 minus 304. So that's 14 units below the mean, but measured in standard deviations, dividing by 8, that's negative 1.75. So it's negative 1.75 or 1.75 standard deviations below the mean. So it falls between those two. It's not exactly half. It's actually further. But the reality is that's a curve. So even if it was half, I can't just split that area in half because it doesn't work. So how do I go about this? But we've talked about that. We've talked about because the normal curve is consistent and predictable, that at this point we have the fact that the probability is less than or equal to 290 is the same for any normal curve where you're asking the area below negative 1.5 standard deviations. It wouldn't matter. If we had another problem that fell in the same place, the area below, it would be the exact same answer. And the key there is the words consistent and predictable. Because that's consistent and predictable for all normal curves, we're going to count on calculus. We already said the 68, 95, 99.7 rule came from calculus because areas under the normal curve were not something we could calculate. They're not from geometry. They're not rectangles. They're not triangles. They're these curves. We got those values from calculus. Well, the reality is because they're consistent and predictable, calculus has calculated all of these other values for us, and we just need that book or table of values to be able to look this answer up. So that's what we're going to do. So let me show you how to do that. Okay? So you have access to a table. The table looks like this. It's a 2-page table. The first page says negative z-scores, and the second page says positive z-scores. And you can see in the picture that when it says positive z-scores, we're talking about z is above we're talking about scores above the mean. And when it talks about negative z-scores, it's below the mean. You'll also notice that the area that they shaded is the same area that we shaded, to the left. So if I go back a page, I notice that this picture looks an awful lot like our picture that we were just working with. This here is kind of like ours, as long as z here is negative 1.75. Then that's exactly the area we want. So how do we use this table? Well, if you look closely, and I'll zoom in a little bit here. Whoops, no, I won't do that. There we go. Zoom in a little bit. You'll notice there's z values that are down here, and they're technically across here too. So how do I use this table? Well, I go down and I'm looking for a z-score of negative 1.705, and I might have to scroll up. Nope, I did it. So negative 1.7 is there, and 0.5 is here. Okay? So that put together gives me negative 1.75. So this is the first decimal place over here, and then the column is the second decimal place. So if I go across, and I come down, and I match those up, it helps if you hit it right, the area that falls, that picture that we were just talking about, is 0.0401. That's the answer. For a z-score of negative 1.75, the area below that, all the way forever, is 0.0401. So let's go back here. So wait a minute. Using that table, we just found out that that area from negative 1.75 and back is 0.0401, and we found out that that means the probability that a random drive chosen of Roy McIlroy's is no more than 290 yards is 0.0401. We answered the question. All we had to do was find the z-score and look it up on that chart.